Good day, everyone. Today we are dealing with the unit circle. Yay! Finally made it here, y'all. All right, today we will create our unit circle by converting degrees to radians, convert radians to degrees, explore trig ratios further. Also, we will review percent change and factoring cases 1 through 5. That's something I will give you in a Kahoot for you to do. All right, participation log. Again, you guys are doing good with these participation logs. And of course, I'm going to continue with them because you guys are doing so good with them. You know, you guys are fighting getting them participation points. Like, y'all be working me. But that's what y'all needs to do. I need that energy given all the time because you guys are going to make it through this class if you guys could keep at it. Now, going into the details, remember when you are, running through things you learn, just give me a little detail, not much, just a little detail, to show me how well you are paying attention and you are giving me the effort. Be sure you are part of the discussion. That's how you get my attention, which that's what you want. Cause you know how sometimes I walk around and pay you no attention? That means that you probably was doing it, but then you stopped. I wasn't too impressed. Make sure you guys, keep getting my attention by being involved in the discussion. Copying notes is cool, but I need more math involvement. Because again, you're not going to pass this class simply just writing notes. You may say, oh, that's doing your work, but the thing is, you're not doing it to understand it. You're doing it just to try to get some points. Ask questions, agree and disagree. Staff them phones could get some of you guys gonna fail because these phones gonna put you. You're gonna see me next year because you ain't doing right. All right, y'all. I decided to change up how the way I was doing participation because you guys demonstrated that you guys really do want to learn. You guys did. So now I want to step it up. So when I walk around on these participation logs, I'm just grading you on these few things. This is what I'm gonna put on your paper. Instead of checks, I'm gonna put letters. D. If I put a D on your paper, that means you're just writing notes. You're not really trying to get behind the stuff. So I can't really do nothing with that. And just because I put a letter grade, a D doesn't mean you get full credit. So I want you guys to understand that. D is just you getting the bare minimum of points. All right. C means you are not only just taking notes, but you're also talking about the lesson with the people. That's C. So you not only you are just writing the notes, but you're also talking about the lesson with other people. And of course, if I'm hearing it, that's why I know what's up. B, you are asking questions too. So when you get that B, you are writing notes, you are talking the lesson with the people, and you are asking the questions, talking to me. A, you going to the board, you rushing to the board to get some points. All right. And S, you doing it all. That means you writing notes, you are talking about the lesson with people, you are asking the questions to me or to anyone, you are going to the board, and also you are to a point where you even catches me in a mistake. Because sometimes, yeah, I be throwing mistakes on purpose, but most of the time you guys just don't care enough to catch them. So I have to, of course, don't make them. But when I do, you could tell, oh, he means this. And usually I, stop myself and tell you I did something wrong and fix it. So if I said, well, okay, well, I walk by you, that means, okay, you just took notes. Cool means that you did both take notes and talk to people. When I say show enough, that means you are asking questions, talking to the people, and writing notes. While you're going to Bob said working it. So that means you worked it, you ask questions, you talk with people, and you are writing notes. When you give me finally the ooh ah ah, that's the ooh ah ah sensation. That's when I'm all in it. I mean I'm feeling good because you hyping me up. And that's you going to a bar, you really doing your stuff. Now, do I care if you're right or wrong with your answers? No. That's the reason why we do this in class. It's practice. It's just you can't make these mistakes on the test. Remember, you're going to get it wrong before you get it right. MATH spells mistakes allow thinking to happen. That's math. Don't forget that, y'all. During that math class, ask them questions. Share your thoughts as it pertains to the class, meaning lesson, always. Help people when you feel confident. Don't put down anyone. Don't trash talk about people. Da, 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 da. Don't do any of that. You know, you guys want to be treated like adults, and adults don't do all that. Those who do, they're not real adults. They're just children. They just adult age, but they really are children inside. Skill and effort matters. Yeah, this is not weeks where you gotta show me what you know. Because again, Algebra 2 is the course where most people do fail it. So I want you guys to think, oh, you're gonna pass through by doing the same stuff. If you not giving me enough, you gotta do something about that before it's too late. Quiz. Um, quizzes from the three videos regards to Pythagorean and the unit circle on Tuesday, November 1st, and November 2nd on B Day. If you miss the quiz, it's a 0 out of 250 until you take the test. And you have 3 days, not prior, that's 3 days afterwards. 3 days mean when you come back, and as long as your absence is excused, make sure your absence is excused. Okay. Now let's get back to the Pythagorean. There is circles and special triangles. All right, y'all. Here's a definition that you must remember, and I will be asking you this on your quiz. The set of all points on a plane that are fixed distance from the center. So basically, we're talking about the edges of this circle, and we talked about a fixed distance. Again, a circle is a set of all points on a plane that are a fixed distance from the center. So, y'all, what could that possibly be called? Your radius. All right. And the edges of the circle is just the x and y points that you deal with. And that's going to come into play. And you see a picture of this right here. You see a picture of this right here of where we talked about. H and K is that center point. And X and Y, of course, is just points. But do not forget, like we just said, that that the circle is itself all points, the H and K is a point too, on a plane with a fixed distance from the center. So if this h and k is the center point, and this xy is a point, and you just a fixed distance, that's it. So again, all this is just saying that this is what it looks like. And from the previous video, we start creating an equation which will help us with the Pythagorean. And we know that the R, we'll talk about that momentarily. So remember this formula. So outside x minus h square, because it's outside minus the inside, plus y minus k square equals r squared. That's the standard formula right there we use for a circle. But remember, r is the radius that we always trying to find. Because again, a circle means that you have points that are the fixed distance. That radius is that distance that you are talking about. And remember how we find the radius when we're dealing with points. You just take square root of both sides. And what happens to that r squared? Remember, r squared and the square root, they cancel out each other because they're opposites, and that equals r. Remember, the square root is equals to x to a half power, and so when you have x squared and then you have x 1/2, well, 2 is the reciprocal or the multiplicative inverse of 1/2, and 1/2 is the multiplicative inverse of 2. Let me write this over here. So again, 2 is the multiplicative inverse or reciprocal of 1/2, and then 1/2 is the multiplicative inverse or reciprocal of 2. All right? So they cancel each other out. You're going to need this to deal with the updated Pythagorean theorem. And here we are. Again, Pythagoras, the guy who created the Pythagorean theorem, used a circle, which we know now the circle is a set of all points, being your x and y, on that plane, which is what you see in the coordinate plane. And while you're dealing with this point being a fixed distance from the center, so there's x and y, and then this center right there. And we know that that distance is called the radius. But now let's think of the Pythagorean theorem that we know of. R is called what in this case? And we know the three parts of the Pythagorean theorem, right? R, the radius is the hypotenuse, or hypotenuse, however you want to say it. X is the adjacent leg. I'm going to abbreviate that ADJ. You could do that too. And Y is the opposite. I'm going to abbreviate that too. So this is really how the Pythagorean came to be. So, but look at the details of this. Since looking at this circle, the center is at the origin, this is the formula for this Pythagorean theorem. So x squared plus y squared equals r squared. This is the new Pythagorean theorem that you are knowing now. This is the new one. So no more a squared plus b squared equals c squared. Well, there will be some of that, but when you are dealing with a circle, circles, you know this is x squared plus y squared equals r squared. And again, because the center of that is at the origin, 0, 0, that's why you don't have h or k. Remember, because the center is at the origin, 0, 0, you don't have a h and k. No h or no k. All right, I think I said that enough. All right, let's move on. All right, so part of the thing that's going to help us build our unit circle is we got to know about the special triangles 30, 60, 90, 45, 45, and 90. And they get their names from because 30 plus 60 equals 90, and that's that 90-degree angle right there. And 45 plus 45 equals 90. And again, that's the 90-degree angle right there. So that's where those names come from. Before we go, we have to address the square root and squares and exponent power rule. Now remember what I told you earlier. Like for example, if I have an exponent of x squared, and then if I have an exponent of square root, guess what's going to happen to those? They cancel out and I'll be left with x. Remember that. Like for example, we know that 5 squared is 25, right? But we also know that the square root of 25 is 5, and vice versa. And again, a square root has an exponent of 1/2. So 1/2 is the reciprocal of 2, and 2 is the reciprocal of 1/2. Do different colors so you can see what I'm trying to do. All right, we good so far? Again, in any part of the video where you don't get, just stop and repeat. That's what these videos are made for. Oops, I forgot about simplifying radicals. Um, in this particular lesson, you have to know how to do that. So, 81, we know that that is 9 because A1 has a perfect square of 9 because 9 times 9 is 81. What about 20? Do we know of a number times itself gives you 20? No. But can we think of a perfect square times another number that gives you 20? So let's break this down to factors. So we know 10 times 2 gives me 20. But we also know 5 times 2 times 2. If we break this down, we know that 2 times 2 is 4. And we get 4 times 5. But we know 4 is a perfect square, right? And that 4 is, the square root of 4 is 2. 5 don't have a perfect square, so you leave it like that. Just like that. All right, let's think about 96. So, again, break this down till you could think of perfect square. So I could think of 16 and 6 because 16 I know 16 is a perfect square of 4. So I could put that out. And also the square root of 16 is 4. Do we know the perfect square of 6? No. And you are finished. All right? Just like that. All right, power rule exponent law. You guys gonna definitely have to know this. So let's do this. So with a power rule exponent, just like when you have a number outside the parentheses, you gotta multiply this. So for the first one, we get 4 squared plus a. 3 times 2 is 6. And we could simplify that because 4 squared is 16, and that's a to the power of 6. All right, so let's do this one. 0 times 4 is 0, but 4 to the power of 4. So 4 to the fourth power, or 0, we know anything to the power of 0 is 1, so 4 to the power of 4 is going to be just 256. Just like that. All right. Not yet. I'm not ready for you to go build that unit circles. Not just yet. All right. So let's get started with this. So we've seen this before because of the simplifying the square roots we did. So to deal with these problems, you have to put this back in the radical. So how are we going to do that? Well, remember radical square root. What's the opposite of square root again? X squared. The square root opposite is x squared. So let's square 10. 10 squared is 100. So what's 100 times 10? We should know that to be 1,000. And to check your work, if you want to, you see this 100? Well, the square root of 100 is 10. Just like that. All right. To do 3 over 20, we know that 3 squared is 9, right? So 9 times 20 is the square root of 180. All right. 2 to the square root of 7. Let's do this. 2 squared is 4, right? 4 times 7 is square root of 28. Just like that. Hey. Back to it. So now we could do it. So suppose I was trying to give you the opposite layer to be 6, but the hypotenuse to be 12, and I'm trying to find out what the adjacent is. I don't know what that is, but I'm trying to find out. How would you do that? Well, Guess what? Pythagorean theorem is in the case. So, in the past, remember told you we no longer going to use a squared plus b squared equals c squared? Because now I want you to start using the stuff that we did with the circles. So we know that the opposite leg is my y, and the hypotenuse is my radius, or my r. So let's do it. So we don't know what x is, so that's x squared plus 6 squared, because we know what that is, and we know what 12 is. All right, so let's do it. So we got 36, well, x squared plus 36 equals 144. Now remember, you got to get x by itself. So let's do it. Subtract 36 from both sides. 144 minus 36. What could that answer be? 108. All right. So now, square root both sides. Because remember, because this x is square, the opposite of square is square root. So it's going to be x equals 108. But we got to break that. It's x equals the square root of 108. So we got to break that down. Because we can't have that. So remember how we broke down the radicals from what we did earlier today? If not, go back to that part of that video with the square roots and look at how we broke things down. So when you break this down, I realized something. It's going to be 36 times the square root of times 3. So we know the square root of 36 is what? 6. And we know the square root of 3 does not have a perfect square, so it's this. So x equals 6 square root of 3. And we just figure out what x is. Just like that. All right. So what can we say about the 30, 60, 90 triangle? Well, in the 30, 60 triangle, the measure of the hypotenuse is twice of the opposite leg, of course. But the measure of the other leg is the square root 3 times of its opposite leg 30-degree angle. So let me explain what this is talking about. So going back to our triangle, we started off with 6 on the opposite leg, right? And then on the hypotenuse, it went 12. So of course, from the opposite to the hypotenuse, it doubled. For some reason, I'm tripping. So that's what happened. From opposite to hypotenuse, it doubled, multiplied by 2. But from the hypotenuse to the opposite, it divided by 2. Or it halved. All right? But we also notice that the adjacent leg was 6 square root 3. So that means from the opposite to the adjacent, it went by, it doubled times 2 square root of 3. So basically, this is all what you want to know about 30-60 triangles. So the opposite leg is going to it's going to start off with 6. And whatever the opposite leg is, it's going to remain the same in the adjacent, but it's going to square root 3 times. And then for the hypotenuse, it's just going to double. So opposite by itself, the adjacent by itself times the square root of 3, and then the hypotenuse double from the opposite. All right, y'all. Let's talk about the 45, 45, 90 triangle. All right. So suppose I give you the same scenario, 2 square root 2, and I give you 4 for the hypotenuse. So let's work this out. Well, let me take this back. What if I was to give you 2 square root 2 for the x? So now, let's do it. So we got 2 square root 2 square plus, we don't know what y square is, but we know r square is 4 square. So how are we going to take care of the x? Well, remember what we did in the video about that? Go back to that part of the video and replay it if you don't know it. So power rule says distribute your power of 2 from the outside to the in. So 2 squared is 4, but we know that the power of 2 and the square root, they are inverses of each other, so it's going to be 4 times 2. Getting rid of that square root. 4 times 2 is 8. We know y squared, and we know this to be 16. All right. So subtract 8 from both sides. 16 minus 8, that's 8. Square root both sides. And we know that we know square and square root cancels out, so that's y equals square root 8. If you break that down, you're going to get 4 times 2. And you know 4 is a perfect square, so y is going to be 2 times square root of 2. Again, take your time, replay this if you do not understand it, because I promise you, going through this video without understanding it, you're going to fail it every time. What can you say about the 45, 45, 90-degree triangle? You can say in the 45-degree triangle, the measure of the hypotenuse is square root times the measure of the leg of the hypotenuse. So let's get to it. So going back to that triangle that we did, we had something with a square root of 2 times square root of 2. And then we have something times 4, I believe. Whoa, why you said the hypotenuse is 4, Mr. H? So, let me explain why this is 4. So, in the previous triangle we did, we realized that the x was 2 times square root of 2. Well, to do this, square plus 2 times square root of 2 square, and we get 8 plus 8, which is 16. And you know, we take the square root of both sides. I'm sorry, I wrote that so bad. We get r equals 4. So that's where arcs come from. So in theory, in a 45-degree triangle, the measure of the hypotenuse is 2 times the measure of the leg of the triangle. So in hindsight, this is what it's telling you, that wherever this leg is, it's going to be the same. And then for the hypotenuse, so you can understand where 4 comes from. We just take 4 and we just times it by the square root of 2. So that's what we know. And that's what that comes from. Just that. And let me show you again. Let me show you some detail. 4 times square root of 2. If I was to put that in, we know 4 is the perfect square of 16. So 16 square root of 2 is what this is saying right there. I'll give you some more examples on that when we do that. So let's just keep it going. Yay! It's conversion time. My all-time favorite, because this is so easy. And we're almost ready to put that circle together. All right, for degrees to radians, only thing you gotta do is degree times the pi over 180 equals the radians. I'm gonna show you this one because this is the easiest part ever. So let's. Here's my pen. I was looking for that. So what if I was to have 10 degrees? If I'm trying to convert it to radians. So watch this. Pi over 180 degree. So when you multiply this, it's going to be 10 pi over 1 over every pi. I mean over 180 degree. So this simplifies to just 1 pi over 18. And that's all you have to do. Just that. Just like that. Let me rewrite this pi for you. That's all you have to do. Simplify it. For this, you have to know how to simplify. All right, so let's go from radians to degrees. So say if I was to say 1 pi, or pi, because pi is understood to be 1 pi, over 18. All right. And all I'm trying to do is go from radians to degrees. So that's my radians times 180 over pi. So that gives me 180 degrees over 18 pi. And guess what? 180 divided by 18 is just 10. The pi's disappears, and guess what? I got 10 degrees. Just like that. The easiest thing that you ever had to do in this. All right? It's time to create that circle. We've ready. Let's go, y'all. So look, all you have to do, how many degrees are in the circle? 360, right? So from in quadrant one, what is the highest degree I could have in here? So it's going to be from 0 to what? 90 degrees. It's the highest. And they're going back to those triangles that we was working on. And I'm going to tell you a little bit more about that. So at quadrant 2, I got 90 degrees right here. What's the highest degree I could go into in quadrant 2? 180. Okay, what about quadrant 3? What's the highest I could go into there? 270. And we know in quadrant 4, the highest I could go is 360. All right. I promise you this is going to set you up perfectly. So let's put everything together, get our boom, boom, pow going on. So remember the 30, 60, 90 triangle and the 45, 45 triangle? That's what's coming to play. So let's do it. So 30 degrees, because that's the degree in that angle, in the 30, 60, 90. Let's just create it. So I have a 30 degree right here, but I also have the 60, because that's the degree, because 30 plus 60 is 90. So now let's do the 45, 45, 90 triangle. Well, because 45 repeats twice, you only have to do it once. And we know 45 times 2 is 90. Bam. You creating that circle. Look at you go. You are so smart. All right. So how am I going to do all the other triangles? I mean, do all the other quadrants, because I did quadrant 1. So here's a trick to helping you out. In quadrant 2, why don't you go 180 minus 30, 180 minus 45, 180 minus 60. And that's going to help you create those triangles. And you could do the same thing in the 270. 270 minus 30, etc., etc. So you do that. We're going to create it. And then next period, you're going to have a quiz and the rest. We're going to have all the details. All right. That's it. Homework. Finish what we started with the unit circle and then review it for the quiz. I will have a cheat sheet for you to review all this in the third. All right, y'all. Good day.